Welcome again, chemistry students, to our continued set of videos and screencasts on our mixtures, or our chapter on matter. Here we are at mixtures, and that looks tasty.
That looks delicious.
Alrighty, so this is an example of a mixture.
Yes.
How can you tell? How can you tell that that is a mixture? Take a look closely at that picture. What are some things in there that help you to distinguish the phases? And how can you tell that it is not a pure substance?
All I can think about is what I would eat first. Would I eat the little cereal pieces and save the marshmallows for last? Or would I eat the marshmallows first and save the cereal for, or just wash the cereal down the sink?
As good scientists, we probably should do some extensive testing
I think we will.
Yeah, we'll be back in a minute.
Yes.
Okay, so classifying mixtures. We need to know what they are and then how we tell them apart, and because there happen to be some different kinds. So let's first look at a basic definition. Physical combinations of two or more substances that retain their own properties. Now this is a physical combination, so we could just stir it together.
Right, they're just sitting next to each other in a container.
Right. They may be intermixed and intertwined, so you can't really tell. It's not like in the cereal example, it's not like all the marshmallows were on one side of the bowl and all the cereal pieces were on the other side of the bowl.
That would be awesome.
It would.
If I could put my laundry in the dryer and have it come out with like all my shirts on one side and my socks on the other, that would be great.
Yeah. Unfortunately, life isn't that simple for us. But the other key is that the substances retain their own properties. So back to the cereal example, you can tell the marshmallows apart from the cereal pieces because the marshmallows have a set of characteristic properties.
They're all marshy.
Yes, yes. And the cereal pieces have their own properties.
Cereally.
Yeah, thank you. Those are the scientific terms for that, by the way.
So we've got two broad classes of mixtures. There's homogeneous mixtures and heterogeneous mixtures, and there's a big difference between the two. Homogeneous mixtures are uniform throughout. There's an absolutely even distribution of all of the components of a mixture throughout everywhere. For example, coffee. Coffee would be a perfect example of a homogeneous mixture. The first sip tastes just as strong as the last sip. Homogeneous mixture. Jello. I mean, plain Jello.
Right.
Not with fruit and stuff.
Yeah.
Plain Jello is a homogeneous mixture. Heterogeneous mixtures, on the other hand, each of the component parts is identifiable and separate from the other parts. So here's a picture of a chef's salad, and everything is separate and identifiable. And if you don't want the tomatoes, then you can put them on my plate. If you don't want the radishes, then you can take them out and put them on Mrs. Gregory's plate. You could eat all the ham pieces first if you wanted to, because everything is separate and identifiable.
Now, we'll be looking at some mixtures in class that aren't going to have pieces that are that big, but you'll still be able to tell the difference between the heterogeneous mixtures and the homogeneous mixtures based on their appearance in many cases, and in part because of the ways that we can separate them.
The tomato juice is almost like, or V8 for example, is almost like a homogeneous version of a salad.
Yeah.
If you don't want kale, too bad, it's in there, and you can't pick it out. If you really don't want bell pepper, too bad, it's in there, and you can't separate it like you can on a plate or a bowl full of salad.
With a fork, which would be an easy way to separate those vegetables and materials in a tossed salad. But there are ways to separate homogeneous mixtures and heterogeneous mixtures, and this fancy schmancy apparatus is one way to separate a homogeneous mixture. This is a distillation apparatus. We have that dramatic and exciting round bottom flask and a distillation tube, a condensing tube there. and we can separate mixtures of liquids based on their boiling points. Now this is one method of separation. What's another method of separation for a mixture?
Well, it depends on the kind of mixture you have. If you have a heterogeneous mixture of liquids, like some vegetable oil floating on top of some vinegar or some water, perhaps you could just very carefully pour the oil off the top, or take a pipette and pull the oil off the top, or use a funnel and drain the water out of the bottom, perhaps.
There's a cool piece of equipment called a separatory funnel that lets you do that fairly easily. But what if the mixture is not a liquid? What are some other ways to separate mixtures that are not necessarily liquids or all liquids?
Right. Well, then again, you have to take a look at the properties of the substances you're separating. You could filter them. You can dirty water,
right,
and perhaps filter it through a piece of filter paper and trap all of the dirt. If you had some sand and some iron, and you wanted to separate only the iron away from the sand, you could take a magnet,
right,
and stir it around in that mixture. And because iron is magnetic, sand is not, you'd pull all the iron out.
That would be a whole lot easier than getting the forceps and a magnifying glass and trying to pick out the little pieces of iron or sand. Yeah. But sometimes there are mixtures of substances that, especially in chemistry, because there's so many chemicals that are white solids, that you can't really tell visually. So you would use one of these other separation techniques. And we'll have a lab, I think, coming up with some chromatography.
Oh, that's a good
to
one.
separate other types of mixtures and inks. That's very colorful and dramatic. And there may be a couple others that you should be investigating when you're going over your chapter notes and looking through your textbook. So see if you can find some other methods of separation as well. Thanks for watching. Make sure you follow up with the next podcast.